Hi, today we are going to talk about continuity. Now you might remember we've mentioned continuity quite a bit, quite extensively throughout the past couple of days. But today we're going to officially define continuity, and it's kind of simple to do. So let's say we have some function going along a curve right here, and at some value x equals c, we can go up to the graph, and at some x value we have x equals c, and we have some value here, f of c, right there. Now, for continuity to really exist, the most simple way is that I can draw a graph without ever lifting up my pencil, which is what I can do here. So the first thing that has to be true is that every point at every x value c, there has to be a value. In other words, we say that the value exists. So that's the first rule, that the value exists. That's more of a question. We have to check it. So f of c must exist. Now next, if we look here, we talked about this the other day, that the limit from the left and the right side, we have to approach the same point. It doesn't have to be the point here, but it could just be any point. But the left and the right have to head toward each other. And that is saying that the limit must exist. And again, it's more of a question. We have to check it. In other words, that the limit as x approaches c of our function exists. And lastly, we have to say that the value must equal the limit. In other words, that the value f of c has to equal the limit as x approaches c of our function. So all three of these must be true. We must have a value, we have to head toward, from the left and right, we have to head toward the same place, and we have to head towards the value. So in other words, for the limit, for a function to be continuous, we have to say that we have to approach the value from both sides. Now, this is an existence theorem, and what that basically means is if any part fails, then the function is not continuous. Is not continuous. If any part fails, that's all that matters. So we can actually kind of check this out here. Down below, let's take a look at number 1. We want to use the definition of continuity. And this is the most important part. It says use the definition of continuity. Anytime they say the definition of continuity, if you don't use it correctly, you won't get any points on this on the AP. So we have to be very careful. So they want to find out if this function, if the line x plus 1 is continuous. Now, we should know automatically that it's definitely continuous. It's a line, but we have to use the definition. So the first thing we have to do is determine if the function has a value at x equals c. So I just plug in f of 3, and I get 3 plus 1 equals 4. So this does have a value. Notice I'm showing my work. 2, what about the limit? Does the limit as x approaches, let me write it this way. Does the limit as x approaches 3 of x plus 1 exist? And that's just our substitution method. So 3 again plus 1 is 4. Equals 4, sorry. Equals, that's an equal sign. Equals 4. And then once I know that these are equal, I can say, I have a value, I have the limit. So I can now answer the question. And this is what we're going to do. This is the third step. Step 3. Ready? We can now say that f of x is continuous at x equals 3. We're always going to say where it's continuous, and that is because the limit equals the value. But remember, we have to nerd it up a little bit. But because f of 3, the value equals the limit here, the limit as x approaches 3 of f of x. And that is our answer right there. But be careful, if you just have this, you're going to get no points for it, because you have to show that they're all equal to each other. And you don't need to put down part 3 there. You can just really just say therefore, because we're saying that the values are equal to each other. That's a little bit nicer way to put it. All right, so for So let's take a look at question 2. Question 2, we have a rational function here, so I'm going to take a look. 1 is the value. I'm going to see if the value exists. F of negative 1 equals, this becomes negative 1 squared minus 1 over negative 1 plus 1. I get 0 over 0. Now, we don't ever write 0 over 0, Mr. Werner. You're right. We get 0 on top, 0 on bottom. Never write that. Now, this is indeterminate, okay? But remember what indeterminate meant, that the value does not exist. Now, here's where the mistake that people make. They go ahead and they find the limit. Now, the limit here will exist, but will the limit ever equal the value? And the answer to that is no, because it has no value. So we're done. Remember, we're just checking for continuity. And if any part fails, then the function is not continuous. So right now, the function has no value. So we can say, now, therefore, f of x is not continuous, and that is because the value, or we should say at x equals negative 1, because f of negative 1 does not exist. And that's all we have to put. It's not continuous at our point because the value itself does not exist. And that's our answer. Any part fails, that's all we have to do. So pause here for a second if you need to. Go back and look those over. This is a very easy test. All right. Part 3, question 3. Oh no, now we get the piecewise. You had one of these on your homework a few days ago. So let's see if you are able to kind of figure this out. So the first thing we're going to look for, of course, is our value. Don't panic. Which one of these has a value attached to it? At x equals 3. So we're looking for that equality, and that's just down here. That's this little piece right here. This is the value of the function. It's that little equal to part. So if I want to find f of 3, I'm going to plug that into my bottom function, like so. And that gives me 10. So this does have a value. Next, we have the limit. Now, this is the hard one, okay? So I'm going to go over this one kind of slow. When we do the limit, we didn't talk about it up here, but remember, when we talk about the limit, what has to be true is that the limit, as x approaches from the left, has to equal the limit as x approaches c from the right. And that's our rule for the limit to exist. We actually, for piecewise, we have to show that. You can get really good at this. This is a lot of work, yes, but we can get really good at this one. So we need to take the limit as x approaches 3 from the left. I'm going to leave a blank space here. Don't put your name in it. Equals the limit as x approaches 3 from the right. So now I have to decide, well, which one of these functions is on the left, which one of these functions is on the right. Well, that's easy to do. I can look at my equality. See, if I have my function here, here it's 3. This is the left side. This is the right side. The left is going to be less than 3, and the right is going to be greater than 3. So I know from my inequality that this is my left-hand limit, and this greater than is my right-hand limit, right there. So my left-hand limit is going to be x squared plus 1, and my right-hand limit is going to be the 2x plus 4. Very easy to do. We're going to see a lot of these, so you want to get used to writing. Some of you guys might be like, Mr. Werner, I'm not going to show my work, I'm just going to put the answer. You can, but you will lose every point possible, okay? Because if you don't show the work, I can't grade anything below it. That's what the AP is telling us. So when I put this in now, we're going to get 9 plus 1 equals, plug in here, that's 6 plus 10. Whoops, so plus 4, get ahead of myself. So 10 does equal 10. Ta-da! So does the limit exist? Yes. So we can say, therefore, the limit as x approaches 3 of my function is 10. This is a long process, I hear you. So the values exist and the limit exists. They are the same, and that's what we want. So therefore, now we can say our answer, f of x is continuous at x equals 3 because the value and the limit are the same. F of 3 equals the limit as x approaches 3 of our function. And there's our answer right here. That's the longest problem you're ever going to do in this history of mathematics right there. It is a lot of writing, I hear you. But make sure you show your work. How many guys want to get a 5? How many guys want to get an A? So let me point this out for you. Ready? You get like 1 point here, 1 point for showing this, 1 to 2 points for your justification. So don't be afraid to show your work. Okay? Alright, so let's take a look at number 4. Alright, this one's super easy from a graph. Ready? Whoops, let's make this 3 and this value 4. I always forget to put those on the paper. So step 1, we want to find the value at C. Well, what's the value at C? It's 3. 2, what is the limit approaching as x approaches C of our function going to be? Well, as we approach, we're coming from the left and the right. We're approaching 4. You don't have to justify, it's not looking for that. And then step 3, well, we don't have to do step 3. Take a look here. It has a value, check. It has a limit, check. But notice, the value does not equal the limit. So we can say, therefore, no, this is not continuous. F of x is not continuous. You can abbreviate continuous at x equals c, and that is because the value does not equal the limit as x approaches c of our function. And there's our answer right there. So remember, any part that breaks it, so let's take a look. Up here, what broke the fact that it wasn't continuous was the fact that we don't have a value. Down here, it's that the value and the limit aren't the same. Very easy to do. Okay? Alright, we're going to pause here. You guys can go on to video 2. We're going to take a look at a little bit more math applications of this. So we're going to do a lot of algebra next hand, okay? I'll see you guys then.